Back for the final video in our three-part series on ionic compounds. This one is Ionic Compound Nomenclature Part 3, naming ionic compounds from their formulas. A little less extensive than having to write the formula from the name as we did in the other two videos. Okay, I'm going to go right to it here. Switch camera. Okay. When you are given a formula, right? Like if I give you a formula, NaCl, okay, you're going to need to name that. You probably know NaCl is sodium chloride. We're going to look at kind of the rules to follow to get ionic compound names from their formulas. Oh, sorry. Okay, things to keep in mind. Cations always keep their name. Whatever their name is on the periodic table, beryllium, strontium, chromium will have a Roman numeral, say iron 2, nickel 1, any of these guys, tin 4, they keep their name. Okay. Anions, if it's coming off the periodic table, you're going to add "-ide" to the root or base name of that element. And we talked about that. Oxygen becomes oxide. Bromine, bromide. Phosphorus, phosphide, and so on. Selenium's a fun one. Selenide. Iodide. Okay, so for the anion, if it's in these three columns, it will take the root of the name and add "-ide." The other thing that you need to know is that polyatomic ions, all of them, will keep their name. You don't do anything to these names when they're in a compound. If you think back to the last video, we wrote things like aluminum chromate. We use the name right off here. So the only name change that happens is with elements in these three columns. They're going to get that IDE ending when they're in a compound. So let's look at some examples. Same type of table, this time though the formula is over here and you're coming up with the name. Again, we're going to write cation. We're actually not going to write cations and anions in the Nearpod, but I'm going to write them here just to show you. All you will need to do is go from formula to name. Okay. Okay, so let's look at K3N. Okay, if you don't know it off the top of your head, you find it and you see it as potassium. So this is K and it has a 1+. Nitrogen was nitride, it has a 3-, just to verify where that formula came from. Okay, 3 comes over and down, 1 comes over and down. So again, you won't need to do this in the assignment. I just wanted to show you that this is the correct formula for this compound. Naming it then is very straightforward. You're just going to say it's potassium. Cation keeps its name. And because it's nitrogen from the periodic table, you're going to call this potassium nitride. And that's it. Put the two names together. All right, we're not going to worry about this column anymore. We're just going to go straight over from the formula to the name. CaOH2. Anytime you see more than one element in the second part of this compound, you know it's a polyatomic ion. All right, I got two nonmetals here, an O and an H. I know it's a polyatomic ion. I know that Ca is calcium. Again, if you're not sure what these symbols are, you use your periodic table. And OH must be a polyatomic ion. So I find it, and its name is hydroxide. I don't change that name because it's a polyatomic ion. They keep their name. So this is calcium hydroxide. Let's look at this one. Al and S. Al is aluminum. Keeps its name. This is just one element, S. So I know it had to come from the periodic table. It's not a polyatomic ion. There's only one element here. So S is sulfur. Sulfur becomes sulfide. The elements here in these three columns get that name change when they're in a compound. Okay, what about NaNO3? So again, put parentheses there. I have more than one element in the end of this compound. So this must be a polyatomic ion, which means it will keep its name. Na, sodium. Cations always keep their name. NO3, nitrate. No name change. Nitrate. Smush the two names together. Okay, that's kind of how this one goes. This one, we've got lithium as Li. Just one element with it, so it's got to come off the periodic table. It's not polyatomic. Oxygen becomes oxide. This is kind of intimidating. A lot of numbers, a lot of letters. We got magnesium, and then this has to be a polyatomic ion. I have two uppercase letters here. Right? Mg has two letters, but one is lowercase. It's just an element. Two uppercase letters like this, you know it's a polyatomic ion. Magnesium keeps its name, as all cations do. I know I need to find out what PO4's name is. PO4 is phosphate. So anytime you see a formula that has more than two uppercase letters there on the end, you know you're dealing with a polyatomic ion. If you don't, if you only see one uppercase letter at the end, you know you're dealing with an element from these three columns. Our last one, SrBr2. SR. I have to look it up. Strontium. Well, I knew it was strontium. You just got to look it up if you don't, though. Br, again, two letters, but they're not both uppercase. So this must come from these three columns, and it does. It was bromine. So this is strontium bromide. Get that name change in there for those elements that come off the periodic table. All right. That is pretty much all we have, those three videos. The next slide in the Nearpod will be practicing that skill, going back and forth between formula to name. If you have any questions on anything, I am available by email, or you can send me a message in Teams. And good luck, and I hope to see you on March 1st, either in person or remotely. I do want to do one cautionary tale. Just been teaching so long. I do understand that all of these, let me say this, cautionary tale. Let me start over. It's really important that you learn how to write these formulas and how to write names from formulas in order to really move forward in chemistry. It doesn't go away if you're taking Chem 2. This is a skill that we will review briefly, but I will assume that you know and can do. It's very important to be able to do this. So I just want to stress that. Do your best on this assignment. If you have questions, maybe rewatch parts of the video, let me know. Thank you. Have a wonderful, wonderful day.